So that takes care of the big box. It's a box that's 5 foot bigger, or 4 foot, whatever your offset. 4 and 5 feet seem to be two numbers that are quite common in the field. That gets these stakes far enough away from the dig that you don't have to worry about them getting run over by trucks and dug up by the excavator. So that takes care of that. So the last thing is coordinate geometry. Huge, 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 in my opinion, as far as a tool for any construction professional that's going to have anything to do with layout in the field. And I think all of you at some point in time are going to have to be exposed to layout, whether you do it as a daily job or whether you do it as an emergency. That's totally based on your job, the job that you take. So coordinates. In the real world so far, in the math world that you've been exposed to since probably 6th grade, coordinates have been exposed using an XY axis. XY, Cartesian, XY axis. So an XY axis is vertical is Y, horizontal is X. Positive is up and to the right, negative is down and to the left. Okay, for our world in surveying, we're going to replace the Y and the X with a compass letters. North is up, east is to the right, west is towards the left, and south is down. So that's one change. In your world so far, a coordinate has been expressed by a bracket with a comma in the middle, and the first one was the X value, second one was a Y value. Okay, in the surveying world, that's not the way we do it. We do it northerly and easterly. So this is really the Y and this is really the X, but in the real world, we use X and Y. In the survey world, we use N and E. Okay, so northerling, which is vertical, easterling to the right. Okay, same as you've always been. Hopefully you've had this. I know you have. Whether you've absorbed it or not, it's a different story. All we have is put the, I'm going to put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, the units will be based on whatever the project is. Could be feet, could be inches, could be miles. In our case, I'm just going to use plain old dimensionless quantity. Each one of these is worth 100, okay? So if I want to find a point that is at 400, 200, okay? It's 2 dimensions. We're not going to get into the 3rd dimension, which is Z, or the vertical control. All you do is go that amount of that number of units in the direction, and this is northerly, of course, and this is easterly. So I'll go up 400, 100, 200, 300, 400. Draw a line. That line represents a line that has a vertical coordinate of 400. Then I'll go easterly, 200, 1, 2, and I'll crisscross. And where those 2 points meet, where those 2 lines cross, is the coordinate point. And it's going to be 400, 200. Okay? So all we got to do is plot them. Of course, if this was a negative, it would be south. If this was a negative, it would be west. Okay, so that's how I determine a point. Okay, let's say I now have another point. This is point 1, and I'm going to label him point 1. And let's say I have a point 2, 100, 600. Same thing. Come up 100, draw a line. 1, 2, 3, 4, 5, 600. Draw a line. That's point 2. Okay, the points tied together define a line. Okay, so the line formed by point 1, 2 would be line 1, 2, and it would be right here. So if I want the distance between 2 points that have coordinates, point 1 to point 2, if I want the distance between those 2 points, all I do is form a triangle. And it's back to basic trig. Okay? I go down here, turn the corner, go across here. The height of that triangle is the distance between here and here. How do I get it? I subtract the norths. 400 minus 100 is 300. The leg of the triangle is the difference between these 2 coordinates. How do I get it? I subtract the easterlings. 600 minus 200 is 400. How do I get the length? Same as you do every triangle you've ever used in your life. A squared plus b squared equals c squared. So all I got to do is take square 300 and get 9,000. 400 get 16,000, get 25,000, take the square root and get 500. So that would be the way you do it. So what does this mean? A lot of people like to remember this stuff. I have no idea why. I have no idea why you want to clutter your brain with it. But some people need a road map and don't need a concept. The concept is Pythagorean theorem. Just find the length to the side. You're done. But you got to have something that means something to you letter-wise. Squared. You got to have a formula, which I have no clue why anybody would want to have it. That's what you would do. Look at the picture. The picture tells you. There's the length I want. If I have this height and I have that width, I can square this, square that, add the 2 together, take the square root and get that. How do you find angles? Same way you've always done it. This may be a new concept to you as far as surveying, but it's mathematically rooted in stuff you've had back in junior high school. It's no different. If I want this angle right here, I'll call it theta. How do I do it? I don't need a formula. I got that angle. I know that side and that side. Opposite over hypotenuse. You guys got that Indian guy running around in your head, Sokatowi, whoever he was. I just remember it's opposite over adjacent is tangent. So if I want the tangent of theta, I just take 300, divide it by 400. If I want theta, I take the inverse tangent of 300 over 400 and I'm done. So that's how you find the angles. They go through some stuff in your book. They give you formulas. I do not have a clue why you'd want to know that. You already got it. Why clutter your brain with stuff you've already got in there? So that's the concept of coordinates. If you have coordinates, I tell you, it's a tremendously powerful tool. I use it all the time. When I'm laying stuff out, I do not do anything without coordinates. Very seldom do I do that. It's a tremendously strong tool. It is the basis of two of the tools you have, whether you know it or not. I've had students come to my office and they're having problems with CAD. Okay? CAD is all coordinate based. It's all it is. It's coordinates, points in space. Our robotic total stations, our total stations, the GPS on the front end of a bulldozer are all based on coordinate systems. That's the theory behind those things. So if you can understand coordinates, you've got a tremendous tool that a lot of people don't realize that they have and don't realize how powerful it is. If you get into it, you can find out that it's a very, very powerful tool. So that's the concept of coordinates. It's just a refresher from, in my opinion, junior high school. So you ought to be able to use it. I'm going to go through something now, a little example problem, and that should close this lecture down. How much time we have for an hour and 20 minutes? Jay?